Hi, welcome to the Commercial Gas Engineer channel. Just carrying out servicing on part 2 of this video of servicing this POTTERTON PROMAX 24 ERP. So what I'm going to do is remove the burner from the heat exchanger and show you how I go about cleaning it and the steps that you should take. Ensure that you isolate the gas supply, and then what you do is you need to disconnect the connections. So I'm going to do for you in a moment, and then we're going to take the burner out. So we got our power off, safe isolation, fuse removed, ensure that there's 3 amp fuse in there. For testing purposes, I have removed my connection on my diverter valve, and thanks for the recommendation. One of my subscribers was saying to prevent overheating, just remove the connection. And what you would do is you just turn the hot water on, running the hot water tap, and when you're putting the boiler in high and low, this will save the boiler overheating. Ensure that these don't go back and forth when you are, and with water coming out, should I say, that when you send these back and forth, water isn't coming out, otherwise they're damaged. But I'm going to show you a few more things on these diverter valves and testing later in this service. So what we're going to do now is remove the burner from the heat exchanger. So we have isolated our gas supply. Okay, gas supply isolated. I'm going to remove our hose. Don't forget to put this back on, otherwise the boiler will lock out. Do remember to check for safe isolation. Although I've turned the power off and I know that this is the fuse, sometimes mistakes can happen. For instance, this, I could think that this is the supply, but this could actually be the supply to the washing machine beneath me, and this could actually be the supply to the boiler, and I think it's off, and then it's not. So ensure that you check electrically for safe isolation with a multimeter and test your multimeter beforehand. Remember to check your fags, your flue, your air, your gas, your safety devices. Keep an eye for your washers. Good if you have spares, but if you don't, put your washers somewhere safe. Okay, so we've got our connection out. So I've got my gasket on there. Alright, sure that you don't lose your gaskets. Okay, now it's time to remove our spark generator and our spark generator lead. So spark generator and spark igniter is disconnected. So should I say spark igniter is disconnected. And then over here we have our flame detection. Have our flame detection here. Okay, our flame detection has been removed. Alright, up here is our spark generator. And just a quick reminder whilst I'm here is that you can get to the shredder valve on the expansion vessel from disconnecting up here. Okay, so just a quick preview on this. So in the previous video you would have seen me just remove the expansion vessel in order to pump it up and drain the water out and so on, but it is easier if you take a screw out up here, push the spark generator one side and then slide over here, and then you can get your shredder valve on here. I'll give you a part number. Part number is 235885, and that will get you your connection. Okay, so we have better access here if we want to get to our expansion vessel. Okay, so now we have our we have to keep this connection. Okay, I got my 10mm socket set and my 10mm spanner in order to remove my burner. I've now removed my 4 nuts from here, and now I need to remove my fan lead connections. Alright. Okay. Gonna push this back round here. Alright. And then what have we got left attached? We have one thing left attached. Let's have a look here. Alright, so we're gonna take off our connections from our air pressure switch. Okay, so the air pressure switch has been disconnected, and our lead here, and we should be able to get our burner out now. Oh, we still got one more connection left. One connection at the bottom, still holding it all in. Alright, and then our burner comes out. Here we have the condition up here. So we want to give inside here a wash down. We can use some distilled vinegar inside here. So when cleaning some of these, depending on the condition, and then I rinse it through afterwards. Follow the manufacturer's guidelines, whether they want hot running water going through and that's it, or whatever they prefer. Sometimes they recommend a tool that can get into the grooves and so on as well. Okay, so also remember when you're cleaning out through here that the fluids are gonna come down through here, and that you have to ensure that you clean the condensate trap out, that it's not full of acidic or any form of debris that is built up with debris. So you want to clean around here. You can use a soft brush like what I have here and clean around. Ensure that you don't damage the insulation at the back, and also afterwards you want to ensure that when you're putting it back that this surface here is quite smooth, so that you get a nice connection up with the gasket when the gasket comes on. So you want to just clean around the unit and rinse it through. Okay, so here we are. I'm just gonna clean gently. Clean through here, clean around, and I'm gonna spray it and just rinse it through in a moment. I've done this already in a previous video, but unfortunately the video deleted and I wasn't able to post the last video. So no need for me to go too excessive, as it was just a few weeks ago that I cleaned this out. So here is my burner. Ideally also I want to check the holes, make sure there's not too much dirt on here. I've just cleaned this out recently on a previous visit. But what we need to do is give it a brush down, give it a clean, make sure that and not damage our insulation here. Just give it a nice clean and rinse through. We also can clean our probes with a file, clean it up or change them, clean them up or change them if we have. Check the gap is 4 millimeters. We've got to have the right gap between here. You can negotiate the gap slightly if need be, but make sure that the gap is 4 mil. I believe it's give or take 0.5 millimeters. Get the manufacturer's instructions. Also make sure that your gasket here, your seal, is good, that it is good all the way around, that it is also shiny and elasticated. Okay, it needs to be shiny and elasticated. So we need the flat side of here along this surface and the window wiper side on the outer. If these gaskets are not changed regularly, or if they're not fit for purpose anymore, what will happen is you'll come to these boilers you may have before, and you'll see all of up here melted. It will be melted because the heat will not be contained within the heat exchanger. It will escape and start melting parts of the boiler and possibly catch on fire. Okay, I'm putting my burner back in, my burner assembly. So what I do is ideal if you have a torque wrench. Okay, what I have here is an ordinary socket set, yeah, but ideally you want one which can get you within a range of 6 to 9 Newton meters. Okay, so we have tightened this up, and then there are ways that you can also ensure that your unit is not leaking. Sometimes you can use a mirror or some glass to see, you can see steam on the outer edges if there is an escape. Sometimes when using leak detection fluid as well, that can be done to ensure that the leak detection fluid doesn't full any of the components and so on. But leak detection fluid can give you an indication if there is a break in the seal. Sometimes a combustion analyzer, a flue gas analyzer as well on the edges sometimes can give you signs, especially if the case is on, it can give you an indication if there's products of combustion leaking from the seal. But ideally it's good to have a torque wrench and follow the manufacturer's instructions to see that you can get between the 6 and 9 Newton meters. Okay, now I'm going to start reconnecting my unit back up to the different connections. So we have our air pressure switch connected. We have connected our black leads to our air pressure switch. We have connected our flame detection connection. We're now going to connect our fan supply connected, modulating connection connected. What's missing? Okay, spark generator. Let's reconnect that. All right, what else is missing? Now our ignition, that's back on. Now time to do our gas connection. Okay, so we've got our gas connection back on, our gas supply connection, and we're going to tighten it up. Okay, ensure that you tighten up connections hand tight first before you get your spanner on there. Any connection, hand tight first. And then anytime that you break into a gas supply, always carry out a tightness test afterwards. Okay, gas supply. Let's open back up our gas supply. So tightness test being carried out, that's all good. Then use leak detection fluid on your test point. Okay, we just need to get our hose connected back up here. Alright, remember this was taken off for testing purposes, so that you can get the boiler in high and low. Remember that we have our connections here, underneath here for our high and low. So we have our adjuster here, and also we have our adjuster over here for when we're adjusting our combustion in line with the manufacturer's instructions. So the manufacturers recommend that when you're doing the integrity test, that is up here on the O2 on the supply, that they want 20.6 on oxygen on the inlet. So that's what we want for good flue integrity. The maximum parts per million of CO that we want from the combustion is 350 maximum. We don't want any more than that. We really don't even want to be anywhere near 350 parts per million CO, and the ratio 0.004. So that's the ratio. You don't really want to go over that. It should be quite well under that. Okay, when adjusting the combustion, do note that on the left hand side here is the minimum adjuster, and if we go clockwise, or should I say anti-clockwise. If we go anti-clockwise, that increases, and if we go anti-clockwise, that decreases. Our low fire. On high fire, our high fire is over here, and if we go, it's the opposite. So if we go clockwise, that reduces, and if we go anti-clockwise, that increases our high rate down here. So another thing I wanted to do a quick recap of things that we learned in the last video. What we did in the last video was we did a stability test on the hot water to check for stability after like 1 minute. Is the temperature stable? Sometimes you'd have people complain about fluctuation when the service is carried out. Sometimes during the service you can find other errors. So when the hot water is on there, if they're getting issues, you can clean the plate heat exchanger out, and that can be an additional job or another job, or change the plate heat exchanger. But ensure that you have the gaskets. I showed that in part 1. Sometimes you come to boilers where the water pressure is low, so the first things you'd go to in low water pressure on these boilers, or many combi boilers, is you would check the expansion vessel charge after releasing the water and isolating and releasing the water. And then also you would check the PRV is not dripping on the discharge. So you would come underneath and you would probably disconnect the PRV or go outside and check the PRV, make sure it's not dripping. And then another thing you have to watch out for, which has caught me about twice in my career, and that's after this has been done and this has been done, the PRV, you're still having problems, and it could be a leak on the system, and you can isolate the flow and return and leave a boiler overnight, but who's really going to do that to see if it's losing pressure from the boiler rather than the rest of the system? Or you could also isolate the flow and return on a boiler and leave them with hot water but no heating, and see if the pressure drops, because you've isolated the heating altogether. So you shouldn't really be getting too great a drop in pressure. But what caught me out was in the past, this pipe here I found this, or even on the flexible, I found it on flexible connections where they are blocked up. So the connection from here going to the rest of the system being blocked. And if this is blocked, then your expansion vessel isn't going to be able to do what it needs to do, because it's not communicating with the rest of the system in order to expand and contract. Okay, another thing we did in the first video, you see high and low, how we got into high and low, the integrity test. We isolated the flow on this side and the return valve on the other side down here. We isolated those, and we isolated the cold water inlet as well in order to carry out work. You can, remember, isolate flow and return on these boilers and still have hot water. You may know that, you may not. Also, we clean the magnet clean out in part 1, clean that out. And that may not be part of your service when you do it, but if you can do it in the time you're there, it's something nice to do to help the client to maintain their boiler. And also check in the case seal. You want to check the case door seal to make sure that it is still good. Combustion. Okay, another thing we did was we cleaned the condensate trap out in part 1. That's up here. Condensate trap was cleaned out. Good to rinse those out. And you want to look inside for leaks. There's signs of a leak here. I'm not sure where this is coming from. Hopefully it is not coming from up here. It may be coming from, possibly that sometimes they come from the expansion vessel, but that would be more likely down here. So there could be a leak up here. So we need to look into that. And we also spoke about what I said earlier about removing the expansion vessel not being necessary, but just move the spark electrode and that will do it. Okay, I'm going to do a quick test whilst I'm here on, quickly show you how to check the diverter valve, because often you'll get clients saying, we have a problem with the hot water or heating, I don't know why, and so on. Often plate heat exchanger is a problem with hot water, or the Hall effect sensor could also be the issue. Look into that, because sometimes it's not always just the plate heat exchanger or the diverter valve. You have our flow switch here. You can check for continuity on these or link them out in order to sometimes see if the flow switch is an issue. But on the diverter valve, it's important to know how to test it. So I'm going to turn the water on. Okay, with the diverter valve, you have the center is the neutral. Center is the neutral, and the left or right is either hot water or heating. So you want to have 230 volts on when you're getting a demand for heating or a demand for hot water on the left or on the right. You should see a difference when it is calling for heat on either way. So you can check that with a multimeter, and I'll show you now how you do that. So can you see the 246 volts? So it is energized in one position. Okay, and on the other side, you do not have any call at all. Okay, but if you change the demand, you'll get a change in voltage. You also can do a resistance test, a dead test on the motor when it's disconnected. And here is our resistance here. But when we check on the other line, it should be an open line. So you can see there, we are checking the other connection, and we have an open line. So that's fine. That's what should be happening on the dead test. Okay, we've got our spring back in, and we've got our connection back in to our motor. Got our power back on, and our unit can be used now. Okay, I hope that helped you. I'm gonna put my screws back in onto here and put the case back on and so on, and carry out my fags, my flue, my air, my gas, my safety device checks. Please leave comments in the section below. All right, until next time. Bye.